Hello, everyone, and welcome. My name is Nathan. I'm a trainer here at Briggs and Stratton Energy Solutions, and I'm joined by my colleague, Daniel Moyer. Daniel,
Uh,
good morning.
Yeah, good morning. Welcome, everyone. I do want to mention this is a NABCEP accredited course. We will be issuing NABCEP continuing education credits. Our email is going to pop up at the end, and go ahead and email us your full name and we'll issue those credits. Additionally, the chat has been disabled, but I encourage everybody to put in their questions, their comments in the Q&A. It's usually at the top or the bottom. Speaking of NABCEP, Nathan, we're going to be at the NABCEP conference, correct?
Yes, we are, right? So Daniel and I will be running some talks at NABCEP, and we're looking to seeing you there. If you're new to the conference world, this is about one of the best conferences you can go to. Lots of training. It's really just a time where we can all come together and learn. We'll be doing talks. Daniel, I'm gonna be speaking about integrating generators into energy storage systems. Or what are you going to speak about at NABCEP?
I'm going to be doing codes and standards, safety codes and standards related to energy storage. So really excited to be there. I hope to see everyone there. Be sure you come by and say hello.
Yeah, not to take away from the talk we're doing today, we are going to be talking about whole home backup using our batteries together with Sol-Ark inverters. But we also do want to mention we're going to be going to Intersolar as well. So if you're going to be down in San Diego for Intersolar, come see us there as well. We'll have displays there and you can check out the product, etc. So as Daniel mentioned, this is NABCEP accredited course. We'd like you to stay through the end if you're looking for those NABCEP credits, and we'll have you send us an email telling us how to make out your certificate with the correct name. There is a Q&A here, so please feel free to drop your questions into that Q&A, and we'll respond. And some of those questions we'll try to answer live. We've got a lot of slides, so I'll try not to talk too fast, but I want to make sure we can get through things as well. So for these energy storage systems, and for this talk especially with whole home backup, we've partnered with Sol-Ark, and we're going to be talking a lot about how to use their inverter, pair it with our latest stackable battery, which you can see on the screen. This battery came out earlier this year, and it's been very successful in the field from both a performance standpoint and from just a market adoption. Customers are really liking this battery. What I like about it is how quickly it goes together. What I also like about this partnership with Sol-Ark is that we're two American companies. We both have American-based tech support and tech support team that often understands and anticipate the questions you might have when you give us a call. So please feel free to reach out during this talk if you have questions, and know that you're going to have a strong tech support team there to give you service after you've installed. Now we're talking about whole home backup. As we start off, let's mention the fact that Briggs and Stratton has been making whole home backup generators for a long time. We have a full line of air-cooled generators that you see on the left side of the screen there, quite suitable for backing up power in your homes, as well as a line of commercial liquid-cooled generators. Daniel, what's NG Max?
So all of our standby generators operate either on propane or natural gas. One thing I think a lot of people don't realize is generators derate when they run on natural gas. We have some unique technology, the ignition timing, the exhaust, the intake manifold, that when we do run on natural gas, our generators don't derate. So it's a really cool technology that allows you to get the most out of your natural gas supply.
Yeah, and that's a good point. And that deration for many competitors' generators, like most customers actually run off natural gas if they can. Propane's got a little bit more energy in just in the fuel itself. And so when you run off natural gas with our competitors, oftentimes you're not really getting what you're paying for. You might be paying for a 20K generator, but you're losing about 10 to 15% in that derating if you're running it on natural gas. Well, by doing the things Daniel said, having an engine that's optimized for both natural gas and propane, there's no derating with our generators. So you're truly getting what you're paying for. This is not a talk about generators. Just want to point them out at the beginning. This is a typical way most people across the US currently have been doing whole home backup. Right? And they'll utilize a transfer switch, as is shown there in the bottom. That's an automatic transfer switch. And built into that transfer switch is a lot of lot of logic that'll even allow you to do things like load shedding, etc. It's true smart load shedding where the modules, you can put individual modules on things that you might want to get rid of, like the pool pumps, etc. We'll also show the use of that transfer switch a little bit later on, but this is the traditional way customers have been using whole home or doing whole home backup. They've been using a generator, they've been using an auto main sensing transfer switch, and when grid goes out, that transfer switch will connect the generator to the loads of the house and disconnect from grid. This is the typical way of doing this, but it's not, times are changing. Battery and inverter systems are getting bigger and stronger and capable of backing up whole homes at a more cost-effective point now as well. Nice things about generators are, of course, you get long run times. You can essentially indefinite if you're running off of a large natural gas supply, and even propane tanks. It's a cheap way to store a lot of energy, but it's not as, you still have to pay for that fuel. Right.
And I would argue that it's not necessarily that cheap. Some of these generators use 2 to 3 gallons of propane when they're running, and when propane's $3 a gallon, it can be add up. So using the energy storage systems, maybe in combination with the generator, can save fuel, save noise as well.
Yep. Noise, fumes, fuel. I mean, there are lots of reasons why customers are choosing to move to batteries, and not saying that the generators don't still have their place. And in fact, my talk at NABCEP is going to be how to integrate both of those into your home's backup system.
Nathan, we already have a question.
Started. Go ahead, Daniel.
Yeah, thank you. Keep the questions coming, please. It makes this more interactive. Sam's asking, can we please confirm that the SimpliPHI 6.6 will not run on generator backup if utility is still on? So,
sorry, Daniel, I have a little bit of trouble hearing you. If you'll go ahead and answer that question, I'll try to get
yeah, of course. I'll try to make sure my audio is better. If you do have utility, you're not going to be running the generator. The generator is only there when you don't have enough solar to charge up the batteries and cover the home loads. If you have utility, the utility is going to be responsible for covering the home loads and charging up those batteries.
Okay, thank you, Daniel, and I can hear you now. Let's just get started off by speaking about the components for an energy storage system, the components for a battery backup solution here. So batteries are, of course, DC electricity, just like solar panels, and batteries can't just automatically power your house, right? We have to have that AC signal, and that comes through an inverter. Well, one of the things I like about Sol-Ark inverters, it's an all-in-one inverter. It's got the transfer switches built in, your interconnection devices. It's got the ability to take solar into it. It's got your charge controller built in for the battery, so it can not only discharge your battery and turn DC electricity from the battery into AC electricity to power the home loads, but can also charge up that battery without additional equipment. It's really an all-in-one, and it even has the ability to take in DC solar or AC solar. So if you've got a microinverter retrofit job that you've got to do, Sol-Ark can work for that. It can do both AC and DC solar at the same time. You can also bring in a generator for that backup support. And just run off your batteries, coast off your batteries until the batteries get low in a grid outage. And then you can use the generator to charge those batteries up and turn that generator off. To your point, Daniel, save fuel. So there are a lot of different things that you can do with these Sol-Ark inverters. We're going to specifically be talking about the Sol-Ark 15K that allows us to do whole home backup. So a system looking something like this. We've got our SimpliPHI 6.6 stackable battery. You've got a Sol-Ark inverter, and that would, of course, be able to take in generator, take in utility, of course, microinverters if you've got that retrofit, and then send that power back into the home in the event of a grid outage, or to do things like grid arbitrage to save money on your utility bill. Make sure you're maximizing the output of your solar array. With NEM 3.0 taking effect in California, it's often not very cost effective to sell back to the grid, or it's only cost effective at certain times. Sol-Ark inverter allows you to do specific time of use windows where you say, okay, well, it is, it's 6 p.m. in September. It's going to make me $2 per kilowatt hour to send back to the grid. So there's a lot of programming that you can do in this inverter. We won't have time to get into all of it today, but we will be showing how to do the basic programming for whole home backup and a little bit of the more advanced programming as well. So what we mean by whole home backup is that the entire load center of the house is backed up in a grid outage. So we're showing two versions on the screen. Partial home backup is typically done in which you just back up the core or the critical loads of the house, the lighting, the communication, the refrigerator, the blower motor for the heater, that kind of thing. And so you would install an inverter, but you would put all those loads in a separate panel, not the main load center for the house. And then in a grid down situation, that main panel would be isolated. So we're not using the Sol-Ark to send power back through the main panel onto the grid. And we'd have that battery providing power to power those core loads. And if you also have solar, that solar will stay on in a grid outage, be able to charge that battery up and be able to power those loads. But for whole home backup, we're looking at backing up the full main panel. And one of the nice things about the Sol-Ark 15K is it has 200 amps of built-in pass-through. So you put your disconnect between the main service panel. Sorry, you put your disconnect between the utility service and your inverter. You're able to pass 200 amps right through, if the grid is active, to your main panel. Grid outage. Well, then the inverter isolates itself from the grid, so we're not sending power back onto lines that linemen might be working on. And the battery is now discharging, powering the home. If you've got solar coming in, that's coming in through the inverter, powering the home as well. If you've got enough solar, it might be enough to cover the loads, but also charge the batteries. So that's the difference between partial and whole home backup. The wiring looks a little bit different as well. So when you're doing a partial home backup, you're going to be pulling a certain amount of power off the main panel and running that through the inverter to the essential loads panel. But the smaller inverters typically have smaller pass-through, can't pass all the power from the home through it. Wiring looks very similar on the DC side, bringing the power from the batteries into the inverter. Of course, you want to have a rapid shutdown set up on your inverter, and then you might also have solar, either AC or DC coupling through the inverter. Whole home, looking at a wiring diagram similar to this. This is just with a single stack of batteries. You can also have multiple stacks of batteries if you do have longer duration outages, or you've got more solar, more loads on the home. Maybe you want to keep that AC running for a long time in a hot, humid place. Wiring here, again, we have that rapid shutdown. We've got our DC connection to the inverter. Also available for the 6.6 battery. It is a closed loop communicating battery. With the gateway, we can monitor, thank you, individual modules. So we can look at the temperature inside individual modules. We can look at how those individual modules are doing health-wise. And so for larger systems, we're getting customers wanting to use Energy Track to do that. We can also see some of that battery information in the inverter. So we're running a communications wire between the controller and the inverter as well. So that's your Ethernet cable here.
We did have a question, Nathan. Before we address that question, I do want to hit upon one thing you had said. What we see on the screen is really a new kind of paradigm of what can be done until the advent of the Sol-Ark 15K with that 200 amp pass through, until the advent of more powerful inverters and reliable batteries like our Briggs and Stratton 6.6 battery. Whole home backup really wasn't feasible in the solar realm. So this is really cool to see this new kind of situation that's developed recently. The question, Nathan, is John's asking, keep the good questions coming, is rapid shutdown only for a battery disconnect? And I think I'll maybe address that, Nathan.
Sure.
A lot of times, and try not to imagine that if your house is on fire, the firefighters are going to show up at your house and want to shut down power to the house. They're going to hit that fused disconnect and then thinking that the power is shut down for the house. But in reality, all the Sol-Ark thinks is that it's just another grid outage, and will continue to use energy stored in those batteries to power all of those backed up home loads. Additionally, the AC coupled solar is going to see grid and continue to operate. And if you have DC solar, it's going to continue to produce as well. By hitting that rapid shutdown button, which needs to be located next to the disconnect on the home, it's going to stop all power coming in and out of the Sol-Ark. It's also additionally going to stop the keep alive signal that's going up to your rapid shutdown modules. So if it is AC coupled solar, they're going to see the loss. They're going to shut down. If it's DC coupled solar, their rapid shutdown modules are going to shut down. all power coming in and out of that Sol-Ark will shut down. It is notable though, and I think this is the question, the batteries will still continue to provide power to that inverter, which is still acceptable by code. Nathan, anything to add?
Well, I will add that if the inverter goes down, so I think John's question was really about a grid-tied system, right? So if you do have grid-tied solar, where you are using microinverters with an N-phase system up on the roof, those you won't need a rapid shutdown on that one, because if you lose utility power or if you pull the meter can, those microinverters will shut down. For DC solar, if you've got DC solar up on the roof, the rapid shutdown will shut off the at the module level, so you don't have those high voltage DC wires coming off the roof that are energized, right? So it'll shut everything down. So I think that was getting to the heart of John's question. A good answer, Daniel. Thank you for going through it. In the interest of time, I'm going to go forward, but if we want to come back to that topic, we certainly can. So a system with a battery would look something like this. You might have DC solar on the roof. We're showing those rapid shutdowns there. You're showing a disconnect for the solar. Now that Sol-Ark 15K does have that DC disconnect built into the side. That's the switch you can see in the middle on the left. We are showing emergency stop. That emergency stop will shut off the rapid shutdown. It'll also shut off all the loads of the inverter as well. We are coming through now the Sol-Ark 15K. You do need to have a main service disconnect there that should be either breakered or fused. So you'll want to have a 200 amp disconnect after your meter before that Sol-Ark that is service entrance rated. So as shown on the screen. And then we're showing that what's coming out of that Sol-Ark going into the load center of the house. Now, you could also throw in a bypass switch, so that if you want to work on the solar, if you want to make changes to the solar, you could put a bypass switch in there that could bypass the inverter and go straight to the main load center from the disconnect. So you could either be connecting the Sol-Ark to your main load center or use a bypass switch to connect utility to the main load center. This is a different way to wire it. It's optional. Of course, you can parallel these inverters. So if you've got a big home with lots of loads on it that might have 400 amp service, you can parallel these inverters. So we're showing a larger system here with several strings of solar and a couple of our FOSS 12 battery cabinets. So about 90 kilowatt hours of energy storage on this system, and the ability to output 100 amps of AC continuously through two Sol-Ark inverters. So each Sol-Ark inverter can do, from batteries alone, can do 12K of power, and so 50 amps each continuously AC. Combine those, you can get 100 amps, and so you can parallel those. You could also do three-phase with Sol-Ark inverters by paralleling those as well. We don't see a whole lot of 208 homes, but we certainly did a training last week in which customers were talking about some of the bigger homes doing three-phase 208. And so you can do that for homes or businesses. We're going to focus on split phase here, though. So let's take a look inside the Sol-Ark 15K. You can see on the left side of the screen here, you're looking at the battery input here. So we've got two independent battery inputs. That label there should say positive on the left and it's negative on the right. So I've got two positives on the left here, and two negatives on the right here and here. And then we've got individual 200 amp breakers on each of those positives. The paralleling communications is all going to be on the communications board in the center, as are the DC PV inputs that are here. You can use the generator port as a smart load center. You could also, of course, use it as a generator port, or you could use it for AC coupled solar if you want to bring AC coupled solar. So you can use this as AC input or output on the inverter. And then you've got your input from grid coming in here on the right-hand side. You can fit up to 4-aught. Or 3-aught at least, I think. I think you can fit 4-aught because you can bring aluminum into this, so you can fit 4-aught for your 200 amp aluminum. Or if you're using copper, you'd probably be bringing 3-aught here. And then your output, your 200 amp output. This is not a breaker, just a disconnect here, and this will disconnect your load center if you do need to shut the loads off in the house. We've got our grounding bar here and our neutral bar on the bottom. So wiring is quite reasonable in this inverter, especially when compared to the competition. There's plenty of room inside that wiring bay. Neutral bar might be a little hard, but the wiring is generally pretty simple on a 15K. Got a lot of room to work with. You also have a pinout for accessories. So this is where you're going to wire in your CTs. This was where you'll wire, if you got lead acid batteries, a temperature sensor. Or like most systems that are going in now, you'll have lithium batteries. You don't need that temperature sensor. You probably will have batteries like our 6.6 that have closed loop communications. And you'll get that information coming directly communicated between the battery and the inverter. This is where you'd put your two-wire start. If you have a generator relay, you'd be using pins 7 and 8. We'll talk about that in a bit. The emergency stop is a normally open circuit, and that's labeled B and B there. That you'll need to have an emergency stop built in. Pins 15 and 16 are for the rapid shutdown connections, so the keep alive signal comes out of those. Let's jump into wiring comms for a battery. If you have a closed loop communication enabled battery, like our 6.6, you'll want to connect that to the inverter. So our wiring bay looks like you can see in the bottom right screen on that 6.6 stack controller. You've got one comms cable going out and running to the energy track gateway, and you've got another comms cable running out of the CAN bus port running into the Sol-Ark inverter. We do have a dongle that is included with that controller. That'll get those pins set right for communication with Sol-Ark. If you have multiple stacks, a lot of installers, Daniel, I know you did a 3-stack system recently. So you're daisy chaining your batteries together. Make sure you're coming out of the CAN bus of one, going into the RS-485 port of the other. And do make sure that you use a cable tester if you're making your own cables. I think the most likely issue we've had the most common issue we've had coming into tech support is just, hey, I can't get the communications right. Can you help us out? And what's often the case is you've got a miscribbed cable or you've got a pinched cable, something like that. So this is what the closed loop comms look like for a multi-stack system. Still quite easy to do. You can use that gateway as well here to get individual module.
Nathan, is there a certain type of Ethernet cable we should use if we're running it in the same conduit as power conductors?
Well, I like using shielded twisted pairs, right? You can get unshielded Cat5 or Cat6. I guess the Cat5 versus Cat6 has to do with the capacity of the connections. You'll want to use less than 100 meters of cable. That's a standard for Cat5. So use Cat5 or Cat6 graded cable, but we recommend it using the shielded type, the shielded twisted pairs, especially if you're running these in conduit, which have other AC power running through them. With the amplified banks, the wiring's very similar. No dongle for this one, goes straight out of the inverter port on the batteries. Now, a real battery, this is a battery at the factory. A real battery is going to have stickers on it, etc. But it looks about like this. You don't want to have any open CAN bus ports. Daisy chain needs to have a terminating resistor that tells the communications that's the last battery in the chain. So let's talk just a little bit about the DC connections on the Sol-Ark. Daniel, you recall the maximum voltage of a DC string? We've got 3 independent MPPTs here. What's the maximum voltage we can bring into a Sol-Ark?
I believe it's 550 if I remember correctly.
550 open circuit, right? So open circuit voltage on your panels should be a max of 550. Do take into consideration if you're in a place that gets quite cold, place especially that is dry and cold, that you'll want to do temperature compensation if you're near that limit. And then the maximum operating voltage, the voltage of panels when they're actually outputting power, drops somewhat significantly, about 10 to 15% to hit the max power point, and that should not exceed 500. So those numbers you can get off the labels on your panels. Make sure to not exceed those values when you're creating your strings. Also, if you're paralleling your strings, you'll want to make sure that you have the same number of panels in each string so that you'll have the same open circuit voltage. The amperages can differ. You can even have slightly different orientations of those strings, but you want to make sure the open circuit voltages are similar so that you're maxing the power points. I think, there's a lot more we can go into with maximizing solar. There are 3 independent MPPTs here. You've got enough connections there to bring in 6 different strings. But I don't think this is the talk for it, so I'm going to jump into battery setup. And feel free to stop with questions, everyone. We're going to start talking about how to program, how to set your system up for best possible performance. You want to meet the goals that your customer is looking to achieve with their customized system. So there is some level of customization to this, and everything that we talk about in settings might be slightly different depending on what the customer is looking for. One of the nice things about the Sol-Ark is you can just program it straight off the front screen. You can also make changes on it through the app. You can even do that remotely. So if you have your customer, about to experience some changes that they want and want to have a change setting, you can do that through the My Sol-Ark app. But you can program this straight off the front screen. It's relatively easy. On the right side of your screen, you can see a blow-up of what you would see on the graphical user interface. Looks about like this. If you press the settings in the top right corner, that's where you would get into being able to set up. So let's assume we've completed our wiring. We've got everything ready to go. What we're going to do is we're going to tell that Sol-Ark inverter to expect a communicating lithium battery. So this is quite easy for grid-tied systems, because when you connect grid and power on that grid connection, the inverter should come on. Now, it's not going to turn loads on automatically. You have to hit the start button on the left side of the inverter to get loads to turn on. But the inverter itself will come on, and you can program it. If you're in an off-grid setting, you could start the inverter up with a generator, or you could disconnect the communications cables for the batteries, and then turn those batteries on to turn the inverter on. The reason you might need to do that is that the inverter is not going to be sending the correct signals to the batteries until we get this box in the bottom right-hand corner. You see, so if you go into battery setup, if you go into settings and then battery setup, the battery is looking for this BMS lithium battery box to be checked. Until that box is checked and you click OK, it won't be sending the appropriate signals to the battery. So it could even keep the battery from coming alive if the inverter is not set up properly. There are ways around that, such as disconnecting the battery if you truly need to program directly from battery power. So once that box is checked, you should see an additional box show up in settings, and that's lithium battery info. So as long as everything is connected properly, you've got everything hooked up properly, you've got that box checked for lithium battery info, you'll see this additional green box show up in the settings menu on the Sol-Ark. And you should see some information like this, telling you information about the state of charge of the batteries, their temperature, the charge and current limits, that kind of thing. Once we've got the battery communicating with the inverter, some of the values will automatically be set, and some you can set manually. So the battery capacity should show up automatically. The maximum charge amperage for a single stack I've got programmed in. You can adjust this. This is a global charge rate limit, so it won't go faster than this, and this includes all forms of charging. So if you've got solar charging at the same time as maybe grid charging or generator charging, the inverter will make sure not to exceed this maximum value. So for a 3-stack, it'd be 195. If you've got a different, maybe you've got 6 batteries or 9 batteries, you can look on this table to see what maximum value you could put. Now this is per inverter, and the maximum value a Sol-Ark 15K inverter will do is actually 275. So if you've got a 6-stack of batteries on a single Sol-Ark 15K inverter, the max value you would put here is just 275. That's the highest that you could go to. On the discharge side of things, the inverter is only going to pull a maximum of 250 amps there on discharge, but the battery bank, a 3-stack, can handle up to 273. The max setting you can use for a 15K there is 275. And this box should already be checked. Use battery percentage, and that will allow you to make your settings based on the state of charge percentage of the battery. And you'll see that in the next set of slides here. Now, if we go to the charge tab of the battery setup on a Sol-Ark, what you will see is an independent columns for using generator charge or grid charge to charge your batteries. So if you'd like to enable either of those, or if you've got AC coupled solar coming in through the gen port, you would want to have this box here checked for gen charge. The start percentage is going to be that value if the batteries drop below that value and you have available charging source. So it could either trigger the auto start of a generator, or it'll trigger a charge cycle from that source if solar's not enough to charge it, or if solar's not there. On the grid charge side of things, this percentage here, if you do have a generator connected to the grid port through a transfer switch, it would use that 2-wire start. Or if you're an off-grid, you might have your generator connected directly to the grid. So this is your 2-wire start signal threshold for the grid side, and this is your 2-wire start signal threshold for the generator port side. You can see that the voltages here are grayed out. Those voltages are not being used because we've told the inverter we wanted to use percentages instead of voltage. You can do either, but with the 6.6 communicating battery, if you've enabled the communications, it will automatically select the percentage. You'll also note that you don't need to program the float, absorb, and equalize settings. Those will automatically be set by a communicating battery. If you're using the battery in open loop mode, or really best practice is to go through and set these values to the values they should be with communications disabled, and then come back through once you've plugged in communications, and it'll automatically be set. And that way, if you ever have any issue where communication drops, maybe something happens and communication stops working, it will still go to the correct values. So we can set both of those.
So Nathan,
Yep,
just
ahead.
talked about doing the charge. Now, let's assume that you are in off-grid, and that's what essentially whole home backup is. If the batteries start to run low, certain things are going to start to happen. You can adjust what's known as the low battery setting, and these are based on stated charge of the battery. Once it reaches, in this example, we have it set to 20%, an alarm is going to start to go off. You're then continuing to discharge the batteries. At some point, in this example, we have 10% of the battery's remaining capacity. We're going to shut down. So the inverter is going to stay on, but the loads will stop being supported. We then have a restart percent. What that means is that if the generator, which already should be on, or the solar comes back, will recharge, or grid will recharge the batteries up to 50%, that's when the inverter will start to turn back up on loads. Now, Nathan, what happens if
stay off until you hit that restart percentage? If you don't have grid, right? If grid's not available, if there's no AC power source, those batteries will continue to charge and the loads will stay off until you hit that restart percentage. I'd probably move that down a little bit, maybe to 30 or 40%. You do want to have it above your low battery. It has to be above your low battery value. And you want to make sure to let those batteries charge for a little bit. Typically, when solar's the thing doing the charging, solar comes on slowly at first in the early morning, right? And then it gets stronger. And so in the early morning, when those batteries are just starting to charge up, that solar might not be strong enough to cover the home loads. And so it'll stay off long enough to get those batteries charged up enough to the point where either the solar gets stronger or the batteries can cover loads for some time. So good points. Battery resistance will automatically come through the communications. That should automatically program for you with closed loop communications. Battery efficiency, it's right around 99%. And so that's the value you should program in. Of course, there are some variations in efficiency. If you're doing very fast charges and discharge, efficiency is a little bit lower, but these are highly efficient batteries. If you have the generator coming in, if you've got the generator coming in on the gen port, this is a configuration that you would use here. So we're showing the generator coming in on the gen port, and so that these are your L1 and L2. You'll also run a neutral down from the neutral bar. And you could ground that generator from a common grounding bar as well if you've got one. You could also many times pound in your own grounding rod for a generator if you're doing a whole home system. We also have the 2-wire start coming out of the comms bar and running down to the generator. So you'll want to use a 2-wire start enabled generator or get an aftermarket 2-wire start enabler. And so that kit would allow, or that generator with the 2-wire start would allow you to just run off your batteries till the batteries get low before starting that generator. Save fuel, save wear and tear on the engine, right? Use that 2-wire start.
We get a question a lot of times, Nathan, that is a portable generator appropriate? And yes, you could use a portable generator. You do need to make sure it's a 240 volt output. A lot of the portables aren't always 240 volt. And you are not going to have that two-wire signal to start capability. I haven't seen one on a portable. So that's a really unique opportunity to roll something out, maybe put a twist lock on the outside of the house, charge up that battery, even with a portable.
Yep. And we do get plenty of customers that have a, small, cheap portable that's, only capable of, let's say, 30 amps that want to use that. It does have to be a 240-volt generator. So you can't just bring power in on a single leg at 120. You do need to have a 240-volt generator if you want to use a small portable. And so you could also bring that generator in on a transfer switch. So if you want to integrate a generator into your ESS system, you could also use a transfer switch. And still that generator is going to stay off. That transfer switch is going to stay on grid until it sees power. And that power will stay off until that two-wire start gets triggered. So you're only going to be running that generator when those batteries are low enough to start a generator charge cycle, the settings that we showed earlier. How do you do that generator integration? You'll use pins 7 and 8 on the comms board. Those are the two-wire start signals. That's a normally open signal. You can run that directly in to pins 4 and 5 on our Briggs and Stratton generators. So if you're using a Briggs and Stratton generator, you can run it right into pins 4 and 5. Point out some of the settings for generators. So if you are using a generator that's normally an auto main sensing generator, like our generators, you'll want to disable auto main sensing. And we're showing you the pin to do that, how to do that here with those steps on the left. Also, you'll want to program in that charging. And there are a couple of things to keep in mind when you're using, especially a smaller generator. What would those be, Daniel?
Yeah, those are going to be the auto sense capability. Nathan, we did have a question.
Okay, go ahead. We'll go to
Yeah, what can you do if a mobile generator causes the home's LED lights to flicker and flash?
That's a good question. I don't have a slide on that, but there are some settings that are under the grid parameters in the Sol-Ark inverter. And I would advise you if the generator coming through the inverter is having problems with that flickering. Well, if it's pass-through that's causing that, I'm not sure there's a lot we can do. That is coming from the generator alternator and controller itself. But if the inverter
Perhaps buy a higher quality portable generator.
from Briggs and Stratton,
Yeah, from Briggs and Stratton. To address your question earlier, I don't think I did. You can adjust the rate at which you can charge from a generator to not overload that generator.
Yeah, and the point we're making here is if you do want to use a small generator, bring it in, that you can limit the gen power on the basic setup tab, advanced, and under the battery setup, you can limit how quickly you're charging off your generator. And the point we're making is that when your generator is running and the batteries are charging, the generator is the only thing supporting loads, and it's also the only thing charging your batteries, right? So if well, I guess technically you could still have solar coming in to support that charging. But generally, if the solar is not strong enough to power the home loads, your generator is going to kick on. Typically, this happens early morning or the middle of the night, right? And so you want to make sure that there's enough available generator power to cover the home's loads and charge the batteries at the rate you've set. So this is 60 amps of DC charging coming into the batteries. It's about 3,000 watts. And that leaves, if you had a 13K generator, maybe 10,000 watts to cover the loads in the house. So if you've got a fully electric home that has electric heat, that kind of thing, you'll want to make sure not to overload the generator. When generator is active and when that, let's suppose the grid is down, this is calling for a generator. And so it's either the grid is active on that AC bus or the generator is active. You can't have grid and generator active at the same time. Right, we don't have any grid following generators to my knowledge. So the grid icon here, you'll see a two-wire signal to start going down. You'll see that dashed line on your screen. And then if the generator starts up and the signal is qualified by the inverter, it'll turn into a generator and then you can see power flow coming from the generator. So you'll see that on the front screen. And that's a nice feature, letting you know that, hey, I'm using generator power.
I think that's just one more example of why Sol-Ark is such a great inverter for both our batteries and our generator lineup.
Yep. Yes, it is. It's wonderful integrating generators with Sol-Ark inverters. They're very good. I'd say they're the leader in the market in terms of generator integration. So if you've got an off-grid site, keep in mind, not all companies warranty for off-grid. Sol-Ark does, Briggs and Stratton do. You still get those great warranties from our companies. Here's an example of something you won't see in off-grid. What are we looking at here, Daniel?
Some N-phase microinverters.
Yeah, do these provide backup power if a grid goes down?
Not without a battery to provide that grid reference.
And an inverter, right? You'll also need to have that grid forming ability. So if we add a Sol-Ark inverter to a system on the roof that's something like this, you might see this in retrofits. Customers signed up for solar power 10 years ago. They've got an existing N-phase microinverter array on the roof, but they're looking to have battery backup now or have power when the grid is down. And we can do that with a Sol-Ark inverter. We can bring in a Sol-Ark inverter, which is grid forming, and it's got that transfer switch built in. So you'll disconnect, the inverter will disconnect in a grid outage, but those batteries will allow that inverter to create do grid forming and create a signal that those microinverters can follow. And so this way you'll get both backup power with the batteries, and if the sun is out, you can get solar power to charge the batteries, and those two things can cover the loads in the house. So grid down event, the inverter grid forms and keeps those microinverters online. You can do both DC coupled and AC coupled. So if you've got a customer that's got a small, maybe 3 or 4 or 5K N-phase system on the roof, they want batteries, but they want more solar power, you can bring in AC and DC power. In fact, you can bring in up to 19 kilowatts, 19.5 kilowatts of DC solar, and still have that decent sized AC coupled solar on the roof. The AC solar, of course, is going to feed in on the AC bus, and the DC solar is going to come in on the DC bus. So they are not exclusive, right? You can still use the full maximum input of DC solar. And if you have a big battery bank, I wouldn't do this with just a single small battery bank like we're showing here, but if you've got 3 or 4 stacks of batteries, you might want to upgrade both the solar and the batteries. The other thing to point out about DC solar is it's just more efficient. You're not inverting and then using the charge controller to convert again. So it's about 10% more efficient. You get more energy from your solar this way. It's lower cost, and you're more efficient charging your batteries this way. We looked at this before, but this is showing you where, you would bring that AC solar micro inverters would come in through that gen port on the inverter, and we need to be able to configure that to run appropriately. So on the multi-line diagram, you can see here that we'd be bringing these micro inverters up to 19.2 kilowatts. That probably wouldn't bring in that much AC coupled solar, but I've done systems with, I think we did one here with 16K of AC coupled solar, and it works just fine, right? The Sol-Ark does a nice job of using AC coupled solar to charge the batteries and keep the home alive. The programming, well, the other thing we can do is, of course, bring the generator in on the grid port, but I think this is just a...
And Nathan, just want to pause you. We have 2 people that asked the same question almost simultaneously. Thank you, Andrew. Thank you, Conrad. Can we put a generator in the system as well as have AC coupled solar together? And I think we're going to talk through this slide right now.
Yeah, that's a great question. The answer is yes, right? You do need a transfer switch, right? So you'll need to use a transfer switch, and that's what I'm addressing in this slide here. So if you're going to use that gen port for AC coupled solar, no problem. The one thing you don't want to do, though, the generator typically comes on as those batteries are getting low, right? And so if that AC coupled solar starts to get weak and you're using all that power in the home and the batteries are getting low, but the sun's still out, maybe you've got a small AC coupled array on the roof, you don't want that backfeeding the generator. And so what we can do here is we can install a lockout module. So if you're using a Symphony 2 or a Symphony Choice transfer switch from Briggs and Stratton, this lockout module, which goes for just a little over $100, I think, will turn off. You can include that so it turns off the AC coupled solar when the generator turns on. There shouldn't be, as long as that AC coupled solar is big, there shouldn't be that many cases where the batteries get drained while the AC solar is pumping, right? But it can happen if you've got a small AC coupled array feeding in. So the use of this lockout module, then you can still put a generator in on a system. So great question. Certainly possible. We also need to program that generator port to let it know that, hey, we're using this gen port for AC coupled solar. And so we're going to have this box checked here. And then if you've got the grid on, you'll be able to send that excess power back to the grid by enabling grid cell. So I normally would have this box checked for when the grid's on, the AC coupled solar is always on, and that way any excess power from the AC solar just feeds back to the grid. But in a grid down situation, once those batteries fill up, we want to turn off that AC coupled solar and let it coast off the batteries for a while. So you do need to enable you do need to be able to shut that smart load off. And we have this, typically we'll set this at 90%. If you've got a big battery bank, you could probably take that safely up to 95%, but you want to make sure you're not pushing a lot of power into the batteries when those batteries are full. And so that's the point of having this smart loads panel or the gen port shut off at 90% and allow it to drop down to 80% before it turns back on. And that way the batteries will run for a little bit, discharge down to 80%, and then that solar will come back on and hopefully cover the home loads and continue to charge the batteries. If we want to use that generator port for a sub panel, right? We might want to use that generator port as a load output. We can do some load shedding with that based on battery percentage. So I've shown here on the screen some typical reasons that you might want to get rid of loads or loads that you might want to get rid of in a grid down event based on battery percentage. So we can, out of that Sol-Ark gen port, we can have a sub panel that has some loads that we're willing to shed based on battery percentage. That can be up to 80 amps of continuous 240 volt AC power, right? So a decent amount of power, 19 kilowatts we could put on that. And we could shed that in a grid down event based on battery percentage. So
yeah, and I think this is one of the great features of the Sol-Ark. So
yeah,
really what we're talking whole home backup again is an off-grid home. And when I would sell old off-grid systems, I would explain to homeowners, you wake up in the morning, the batteries are low, the sun comes up, maybe the batteries are fully charged from solar by noon or 1 p.m.
yep.
Once the batteries are charged and you're off-grid, so you can't backfeed the grid, that energy that the solar panels are producing can't go anywhere. It's being wasted. So I would tell homeowners, once the batteries are full, the loads are satisfied, start doing other things. Start doing the laundry, start turning on the radio, the TV, make a turkey dinner for Christmas. With the Sol-Ark, it's automated now. So what we can do is program this so there is no action really needed by the homeowners. It will automatically come on once the batteries are full. And what's a great application, I think, is for an EV charger, right? In the afternoon, you can charge up that EV using the excess solar that otherwise would have been wasted.
Yeah, that's a good point, Daniel. And this is customizable, right? So if you plug in your EV at night and you want to provide a little bit of power to the EV, or if you're running your dryer and you want to run it long enough but you don't want to drain the batteries completely, what you can do is you can set this smart load on percentage at a lower value. So if you want to use, say, 30% of the batteries for those loads, you can keep that load panel on all the way until you hit down to 70% or 60%. It's customizable, right? But it does allow you, it's a really nice feature, as you said, of the Sol-Ark 15K. Keep in mind that you need to have enough battery power to install the inverter, right? You don't want to install a 15K inverter with just a single battery stack like you can see there. Now, that battery with communications will limit the amount of power the inverter is able to output. But if you have a non-communicating battery, like the Phi battery here on the left, you'll want to make sure that you have a big enough battery bank that at the rated continuous output power of the battery, it can match the inverter's drawn power. So each of these batteries gives 1.9 kilowatts of power output. So if you're doing your whole home system with Phi batteries, make sure to use the minimum number of batteries there to power that inverter. Keep in mind, this inverter can surge, right? It can pull 24 kilowatts for a short time, right? And we want to make sure that the battery bank is big enough that it won't be damaged when the inverter's drawing it. Also want to point out that, if you're doing more than 2 stacks, so a single 15K, you could do 2 stacks and combine on the inverter. But if you're using other inverters like the 8K or the 12K and you've got multiple stacks of batteries, you'll want to use a DC combiner and then bring that single combined stack into the inverter. If you've got more than 2 stacks with a 15K, like 3 stacks as you're seeing there, you'll want to use a combiner as well, and you'll want to make sure that you have overcurrent protection on each of those stacks. And so then you'll come out of that DC combiner and feed the Sol-Ark 15K there. On the if you're paralleling inverters, right? So it doesn't matter if it's a 12K Sol-Ark or a 15K Sol-Ark. Anytime you're paralleling inverters, you have to have a single battery bank. So you do need a DC combiner, and then you'll feed each inverter that's parallel. This could be up to 12. You'll feed each inverter that's paralleled off that common DC bank. You never want to feed one inverter from one bank and another inverter from another bank. Always with paralleled inverters, combine your DC batteries. Here's a nice way to combine them. We often talk about the Midnight 1000 amp combiner because that's been kind of the long gold standard for battery bank combiners, the 1000 and 2000 amp Midnight combiners. But Victron just a month ago, I guess probably a couple of months ago now, came out with this Class T power in. And this is 4/0 sized cabling, which you can do individual fuses on. So the negative cables are on the bottom of this. There's some tabs that flip up. I'm actually putting together a guide on using these right now, and it's very well made. And these come in much cheaper than the Midnight combiners. In fact, a single one of these units you can get for under $170, and the fuses themselves are quite cheap as well. So if you're doing 6 stacks of batteries, you can stack these Class T power ins. They're 1000 amp combiner bus bars. They're quite heavy units, nicely made. And so this is a nice option for doing 3, 4, 5 sticks, 5 or 6 stacks of batteries, right? So with individual overcurrent protection, easily done. And so we showed this slide a little earlier. I'm going to skip it now, but remember, when we have multiple stacks, we'll want to daisy chain the communications here. And when you have a lot of batteries like this, it is nice seeing individual battery modules and using that energy track gateway and software. Again, we're showing here the use of a, what is that, Daniel? That's a cable tester. I think your audio's
Yeah,
off.
yeah. I was going to say
Cable
that's a good Christmas present, is what that is. A cable tester.
Absolutely good Christmas present. I think we should even give one away here, Daniel. So I'm going to let you come up with a question for the audience in the Q&A. So if you haven't been using the Q&A, Daniel's going to put a question here as we're wrapping up. And I'd like to see you have a cable tester in your truck when you're doing communicating batteries. Communicating batteries, it's very easy to miss. As our eyesight gets worse, the older we get, right? It's when you're making your own cables, it's easy to miss one of these wires, get it crimped wrong. So those things are relatively inexpensive. I think, Daniel, both you and I have a Klein cable tester that was probably $30 or less, and it's very helpful when you're trying to avoid or diagnose problems. So let's talk a little bit about the My Sol-Ark monitoring as we end, and we'll talk a little bit about energy track as well, and we'll wrap up. And if there are more questions, I think we'll have five minutes or so here at the end. So Sol-Ark has a really nice app for monitoring. It can tell you information about micro inverters, power production from your solar. It can tell you about the amount of CO2 you've offset, or it can tell you about the number of kilowatt hours over the lifetime of your solar that you've been able to produce. And there are lots of different ways to use the My Sol-Ark app, including seeing views like this. I'll typically, when I've got customers that call in that are having a problem, I'll ask them to share their My Sol-Ark. And you can share in 2 ways. One, you can share in a way so somebody can just view the system. You can also share it in a way that somebody can help you change settings remotely. So this is a nice thing if you're doing some troubleshooting. What we can see here is we've got the battery that's shown here, and we're looking at the state of charge here. So we can see as that solar comes out during the day from microinverters, that this person's system is got those batteries charging up. It's covering the loads. You see when the battery goes below, when a battery goes negative, that's the battery being in a charge cycle. You can also see it looks like maybe an air conditioner or something kicking on here. You got a lot of power draw, and occasionally that solar's not able to cover it, so the batteries kick in and cover that extra power, and the power out of the batteries here goes positive for a bit. And so these batteries charge up during the day, and around, it looks like 6 p.m. at night, that sun goes down, and now the batteries start their discharge cycle. And so they're using that power they generated during the day, the excess power they generated during the day, to keep their system running at night. It's a cost-effective way to use your system. It's a way for your system to pay itself off over time. You get that return on investment when you're backing up with batteries and solar. This is information you can see about your battery bank straight in the solar, and this is logged daily, so you can see how your batteries have done over time, what their temperature is, and you can see a graph of their charge and discharge cycles, etc. Now, there's a little bit of difference in power between the charge and discharge cycle. Why is that the case, Daniel?
It can be that the difference, what you're seeing is the ability for the home loads.
Yep, it could be home loads. It also can be a little bit of inefficiencies, right? So the inverter loses about 5% of power when it converts DC to AC. And you'll always, if you're not doing it off of solar, you'll consume a little more on the charge cycle. We're wrapping up. Keep the questions coming. I do want to point out we have high voltage offerings. So Sol-Ark has an all-in-one single inverter that'll produce native 208 three-phase. Well, SimpliPHI batteries come in high voltage battery stacks, 24, 48 volts. So if you're looking for Briggs and Stratton high voltage options, or if you want to make that change, we've got some options for you for both those 480, 277, and the 208, 120 three-phase power. Stacks look something like this. We use the Nuvation stack controllers with our battery stacks. And so if you've got a high voltage project, let us know. We've got a team that does high voltage projects that can help you out. What are we looking at here, Daniel?
We have a great IQ installer program. So we're offering some rebates. We give you $1,000 off your first install. And really, technically, you don't have to be part of this IQ installer program to take advantage of $1,000 off your first install. If you do choose to join, please scan that QR code there. We will give you not only that $1,000 off, but an additional $100 off every battery module you purchase in the future. And we've extended that all the way through 2025. So please.
You do that quarterly, right, Daniel?
That's right. Yeah, we'll pay that off, and that's cash back to you. Please consider joining. Not only will you get eligible for some of these rebates, but you'll also be promoted on our website. You can see the map there as well. And we'll also get a nice newsletter and other emails that will come through. Promise.
We're also going to send you a pack of swag. So if you're looking for that Christmas gift, right, this will be from us to you. So we'll send you a pack of swag that includes some nice clothing, right, in addition to some labeled products, etc. I'd like to advocate that we throw one of those cable testers in as part of our swag pack going forward. So I'll talk to our marketing team and see if we can make that happen. But it's pretty easy to join this program. If you know what you're doing, give Daniel a ring and he can get you into the program. He'll do some interviews, make sure you're a real company, etc. And so one more time, we've got time here, just a couple of minutes for questions and answers. But if you're looking for NABCEP credits for today's course, send an email, energystorage@training.com. Let us know that we'll check the register, make sure you attended, and then we'll send out your credits. Let us know how your name should appear.
Nathan, we got a bunch of questions, but first, you had promised a network tester for a quiz question. I got one for everybody on the call. Nathan had mentioned earlier that you cannot take if you have multiple inverters, say you have two Sol-Ark inverters and you got multiple battery stacks. Nathan mentioned that you cannot take an individual battery stack to one Sol-Ark. You can't take the other to the other. You have to combine them. What was Nathan's new favorite battery combiner? What's the manufacturer of that battery combiner? Please go ahead and put it in the chat. We'll look at that results later, and then we'll go ahead and do a random drawing and send out that battery tester as well. Nathan, is a gateway required for a single stack?
It is optional, but you do need to. So it's a great question. Is a gateway required? So you can choose not to install it. We highly recommend you do install it. But keep in mind that the battery warranty could reduce to 5 years if we go through a firmware update and the battery does not have its firmware updated within an allotted amount of time. I believe it's 3 months after we announce a firmware update. We've never announced a firmware update for these 6.6s, right? We don't have one planned, but a gateway would be required. So you could use the gateway as a service tool to do that update if you choose. We highly recommend the gateway, but we're not requiring it at this time.
Do we have a battery capacity versus load discharge sheet?
A battery capacity versus load discharge sheet. I'm trying to understand.
Maybe is asking, do you have a state of charge versus voltage?
I think that's more likely the question. I will point out that it is true that batteries are less efficient under high loads. So your capacity, the capacities that we advertise are on a C/5 discharge cycle. That means we drain the batteries in 5 hours and guarantee that they're at the capacity that they're rated at. In fact, our batteries are typically about 5% higher capacity than they're labeled as when you receive them. But if the question is just, do we have a voltage versus state of charge graph, then we can get that to you if you send us an email, energy storage training. Daniel, more questions?
Plenty of questions. Thank you, everyone. And Andrew asked something similar. Using a PHI 3.8, can the state of charge be used as a good way of knowing how much battery life is left or voltage?
You can use either one with a PHI. The state of charge that you will see in a Sol-Ark, if you're doing a whole home backup with a Sol-Ark and the PHI batteries, the state of charge that you will see will be approximated by the Sol-Ark. So yes, you can do it. It's not our software that would be displaying that state of charge, so keep that in mind. There are other ways to do that as well. My favorite, in fact, is using the Victron shunt for state of charge, and the Victron has a smart app which would allow you, yes, it'd still be a third-party app, but you can get information that way as well. So you can use a shunt, you could use the Sol-Ark's state of charge calculator to get an approximate value. But I do like having communicating batteries, and I like being able to see that information through my Sol-Ark app. So yep, you can do it with the PHI.
Shannon's asking, I'm not sure exactly, does it require power for the gateway? Does the gateway require power?
The gateway consumes a little less than 5 watts of power, and it is powered by DC power. So we'll connect the gateway. The power for the gateway is drawn from the 48-volt DC bus. It doesn't use much power at all. It's 4 to 5 watts of power. But yes, it does consume a little bit of DC power. Mostly it's probably a little higher if you use Wi-Fi versus using the network adapter instead.
Scott's asking, what's the configuration for adding storage to an existing PV system?
Configuration, I think, let's see if we can bring up a slide just showing adding storage to an existing PV system. So if you had, for example, if you had a system where you were doing like a retrofit, it'd be, could be something like this, where you might have existing solar on the roof, but you're going to add maybe some more solar and you're going to add batteries into that system. It really depends on the type of solar that's there. If you had a grid-tied system and you've got a really old inverter, right? Instead of having maybe N-phase microinverters, let's suppose you have got some old solar edge inverter. You can either AC couple or DC couple that, meaning you could remove the inverter and just DC couple solar into the Sol-Ark. Or if you want to keep that older inverter, you could bring that in as AC coupled. So
we got a couple more questions. You're not going to hurt our feelings if you have to drop off to go to another meeting. Energy storage training is where you're going to email us for your NABCEP credits. Nathan, the PHI 3.8 has a depth of discharge of 80% at 10,000 cycles. The new 6.6 has only 6,000 cycles at the same depth of discharge. Why is that?
Well, that's not quite the case. It's 6,000 cycles at 100% depth of discharge at a 0.75 C rate. Um, I don't know the number of exact cycles at an 80% depth of discharge. It will be lower. It will be a little bit lower than the Phi battery. And that's because we've designed this battery a little bit differently. We've designed this battery for more power output. So in fact, the 6.6 modules can discharge themselves safely in an hour, as opposed to 2 hours for the Phi battery. And we've also changed our electrolyte up a little bit. So we're using cells that can operate in colder temperatures. But ultimately, I think that we've designed the battery for slightly different purposes, right? And by making some changes to that battery to allow it to be a higher power output, to allow it to work under a colder overall temperatures, we're getting a little bit less number of cycles. Still, you do the math, 6,000 cycles, we're looking at 16 years of continued operation. The battery is still warranted to have a 75% capacity at the end of 10 years as well. So at the end of the warranty period, we're guaranteeing at least 75% of its original capacity. So a very slow degrade on the capacity as well.
Yeah, it's an interesting point, Nathan, that not only does the depth of discharge matter for the battery life, but also the rate at which you're charging or discharging the battery. One
Yeah.
last question, I believe. Can you backfeed on the generator port to feed, say, a pool pump while the utility is still on to utilize free power?
It wouldn't be backfeeding, but absolutely. So the battery wouldn't be supplying that power, but absolutely you can use you can power a pool pump. It would either be powering that off of the solar that's coming, or potentially off the batteries if you set up time of use, or it's just a pass through as well if the grid is active. So if the grid is on and solar is on and there's enough solar power, solar will cover all the loads. And generally send excess back to the grid if you've got that enabled. You can set up time of use to make sure your batteries cover loads like a pool pump if you wanted to. Time of use is a way for you to be very specific about when you want to charge and discharge your batteries and what wattage you want them to charge and discharge at. And so it's highly programmable through the Sol-Ark. But I think the answer is yes, you certainly can power a pool pump while the grid is active from other means like solar and batteries. So that's a good question. That was a long-winded answer.
Yeah.
Yes, we can do it. And if you need help, reach out to us. We'll help you.
Yeah, Ronald, again, I think he's clarifying. The question is, if you have one 6 kilowatt, perhaps kilowatt hour battery stack or cabinet, how long will the battery plant last at full or 50% load?
So it's a great question. So a stack of 6.6 batteries is actually 20 kilowatt hours, 3 times 6.65, right? So it's right at 20 kilowatt hours of overall storage. So at a 50% load, a 20 kilowatt hour stack would be outputting 10,000 watts. So that's a lot of power output. Most homes don't use that much. In fact, the national 24/365 average is 1,200 watts. Right? So a tenth of that. So it really depends on the homeowner, but if they're truly operating it at a 10,000 watt load, it would only last about 2 hours, right? So 20 kilowatt hours, if you're using 2,000 watts, would last 10 hours. So hopefully we've answered the question.
And those are all the questions we have, Nathan.
Thank you, everybody. Truly appreciate you taking the time to attend this training. We hope that you've learned something. If you'd like to see other topics that we haven't covered, you will be receiving a survey from us. And as Daniel mentioned, we're going to put everybody's name in the hat. They got the correct answer for that Victron Class T Power In. So if you got that name correctly, it was a Victron Class T Power In. I think we'll just take the manufacturer's name. So if
Exactly.
Victron, we'll put your name in the hat. We'll draw a name out, and we'll get a cable tester sent out to you for Christmas. Thanks, everyone.
Thank you, Nathan. Thanks, everyone.